Hello everyone, welcome back. Tackling some recursion this unit. Upfront, full disclaimer, happy St. Patrick's Day. Not wearing green. If I was, you wouldn't be able to see it anyway. There's a green screen right here. See how my hands kind of got this green hue to it? If I wore green, it would just disappear. So send your pinches in chat, I guess. So today, continue on with our discussion on recursion. We pretty much learned essentially everything there is about recursion yesterday. So going forward, it's a lot of practice. It's doing some coding bats. It's looking at multiple choice questions and trying to trace the recursive routes. And maybe we'll hit up some IntelliJ. So in the future, probably doing some stuff in IntelliJ this week, maybe early next week. So if you don't have IntelliJ installed at home, you need to get on it. So yesterday when we left off, I gave you this coding bat to do triangle. We're going to start off looking at solutions. Here we go. I'm in coding bat. I'm in recursion 1. Here is triangle. It says we have a triangle. We have triangle. We have triangle. We have triangle. Made of blocks. The topmost row has 1 block. The next row down has 2 blocks. The next has 3, and so on. Compute recursively, no loops or multiplication, the total number of blocks in such a triangle with a given number of rows. So here we see that whenever 0 is passed in as number of rows, we get back 0. When 1 is passed in as number of rows, we get back 1. So this should be sending off alert signals in your head. These are our base cases. Now you could look at this as 2 separate base cases. Hopefully you're recognizing this is actually just the same base case, that whatever rows is gets spit out as long as rows is less than or equal to 1. Let me show you. So we're going to lead with our base case. So I'm quickly identifying what is going to cause our recursive call stack to stop. If rows is less than or equal to 1, we can just return whatever the value of rows is. That's our base case. That's going to cause our recursion to stop. Now, we need to think about our recursive step for everything else. I did not actually think about this. What are we returning? Like 1 plus? I don't know. Let's try it. 2 plus? Thank you, chat. Oh, yikes. Why am I getting a Stack Overflow? We have to actually subtract from rows, so it's not enough just to have the base case. We actually have to approach it, right? So this is a triangle. Our rows is, well, getting smaller, upside down triangle. So our rows are getting smaller as we go. Also need a base case for 2. Is that true? For rows is exactly 2. We're returning 3. Oh, they don't like that. Our rows has to be replace the 2 with rows. It's number of rows. Thank you. I didn't actually even think about the problem. So we have our base case, which is going to stop us, right? It's recognizing that these are the simplest entities in our problem set. Whenever we have 1 or less, we could just stop there by returning rows. Otherwise, we hit our recursive step, which consists of the recursive call. This method is recursive because triangle is calling itself. Now, again, it's not enough to just have a base case. We actually have to approach the base case. So rows is actually getting smaller with each recursive call. Sweet. Do we want to trace this? Maybe that's a good idea. Oh. So we'll bring out some notepad here. We can zoom in. Let's just say that we have triangle, which I'm going to abbreviate with just T. Let's do like 5 rows. I'm going to zoom in here. What is our short key? Control plus, just like it is on everything. So let's say that we're starting out with the initial call, triangle 5. First thing I'm going to do is check our base case. Is rows less than 5? It is not, so we're going to hit this recursive step where we're going to return rows. Well, currently that's 5, plus a call to triangle, rows minus 1, or triangle 4. Okay. Here I have the recursive call. It's sitting there on the stack. I don't know what this is yet. I can't actually solve anything until I figure out what this is. So let's step inside that recursive call. So I'm going to ask, is rows equal to or less than or equal to 1? It is not. So we hit our recursive step, which is going to be rows plus triangle of 3. Well, again, I don't know. Well, let's play with this spacing. Oh, I guess that is a tab. That's 2. Okay. I'm going to step inside this call. Is rows less than or equal to 1? No. So we'll hit our recursive call, which is going to be 3 plus triangle of rows minus 1, or triangle of 2. We'll step inside this call. We're going to have 2 plus triangle of 1. And then lastly, we're going to step inside this call where rows is less than or equal to 1. So we just return rows. And so this is the height of my call stack. Notice that the last thing that was added is the first to actually get resolved. So last in, first out. We're basically going to work our way backwards as the call stack collapses. So I can essentially replace this T1 with a value. I know what it is. The value of this is 1. I now know what T2 is. That is triangle 2. I can replace it with this, which is 3. I now know what T3 is, 6. T4 is 10. And lastly, our solution is 15. Thumbs up. Thumbs up in chat. All right. Let's go to the next one. I'll actually think about this one. Given, oh man, you found the pickle with emote. Given a non-negative integer n, return the sum of its digits recursively. Note that mod 10 will yield the rightmost digit. For instance, if we take 126 and mod by 10, we're effectively getting the rightmost digit, which is a 6. We could also divide by 10 to remove the rightmost digit. Don't forget about mod 10, divide 10. This is one of the areas where they're actually kind of most useful. Right? We're going to take in an integer. We're going to return an integer. For instance, 126, we're just adding these digits up. Okay, let's step through this. So I think base cases are kind of where you want to start. Help me out in chat. Give me a base case here. A 1-digit number? Yeah, if there's only 1 digit left, how do you know there's 1 digit left? If n is less than 10, beautiful. If n is less than 10, there's only 1 digit. Okay? At that point, we just return n, whatever it is. So this is a base case for us. It's one thing to have a base case. It's another to actually approach it. We're going to have our recursive step where we basically need to get the rightmost digit. How do I get the rightmost digit? Well, they actually tell us up here, right? We can take our current value, mod by 10. That'll give us the rightmost digit. So n is my current value. If I mod by 10, I now have that rightmost digit just kind of sitting here. Now we want to add that, and we want to make this method recursive. So I'm going to call sumDigits. We're going to pass in n, but if I was just to do n, we're going to get infinite recursion. So I need this value to get smaller. We've already considered the rightmost digit. I now want to shave off the rightmost digit. And the way that we do that, over here, divide by 10. So I'm going to take n, divide it by 10 here. Ta-da! Let's trace it. Give me a number in Twitch chat. Thank you, Jonathan. Let's do... Sure. All right, we'll zoom in. So I'm going to take this, but we're going to do sumDigits. And again, I'm going to just abbreviate that with an S. Okay, so we'll pass in 420 as a value for n. Is n less than 10? No. So we're going to come here, n mod 10. What's going to give me the rightmost digit? That's a 0. Okay, so what we have sitting here is the rightmost digit, a 0. We want to add that with sumDigits of n divided by 10. Well, that's going to chop off the rightmost digit. We're effectively getting rid of this 0. So we're doing sumDigits of 42. Well, I don't know what this is. So I need to step inside this method call and actually start processing. We're going to ask, is the value of n less than 10? It is not. So we're going to hit this recursive step where we take the rightmost digit, which is a 2, and we'll add it to sumDigits of n divided by 10. Well, this is going to chop off the rightmost digit, right? So we're doing sumDigits of just 4. Well, I don't know what this is, so we'll step inside that call. Right? In this case, n is less than 10. So we just return it. This is the height of our call stack. I can now collapse it. The last thing to get added is to first actually be executed. So I can replace this with just a 4. What that means is I now know the value of sumDigits 42. It's 2 plus 4, which is 6. I now know the value of sumDigits 420. We can finish this out. This gives me a value of 6. Sweet. Okay. I have a multiple choice question for us. Then we may actually, you know what? Let's hit the next coding bat. We're looking at count 7. Count 7. Given a non-negative integer n, important to tell us it's not negative. Interesting. Return the count of the occurrences of 7. We want to know how many times 7 actually occurs. Of note, rightmost digit, super important here, right? We're using mod 10, divide 10 to kind of process this. So what we're doing is taking a number and we want to count the total number of times that 7 occurs. For instance, 717, we get 2. Here, 7 just only occurs once, and 123, there are no 7s in that number, so we're going to get a 0 there. So, first thing I want is my base case. Help me out. Simplest entity. This feels very similar. Help me out, chat. Base case. N is less than 10. That'll tell me there's one digit. Sure. If n is less than 10, we got one digit. Yeah, this one's going to get interesting, right? Because it's not just it's less than 10. Maybe it also has to be equal to 7. But what about... Yeah. So, question. If I take a number and I just repeatedly chop off the rightmost digit, what will it hit? What will that number be? Toes, I see you throwing out 0. So there's another possibility. There's lots of ways that you can actually do this base case. To me, it's a bit of a compounded base case. So you have a situation where it's less than 10 and it's 7. You have a situation maybe instead where it's just exactly 7, but then you got to consider all the other scenarios. So we'll play with this a little bit. If n is less than 10, that's not just enough, right? If it's less than 10, if it is equal to 7, we can return 1. Otherwise, we're effectively returning 0. I don't really like the way this is looking. Right? if, as we just talked about, if we just keep chopping off the rightmost digit, we'll eventually hit 0. If n is equal to 0, we can return n. How about if n is 0 or n is 7? We return n. Right? So this should handle the situation where n is exactly 7. You don't like this? You don't want to actually return 7. Right? If n is 0, we can return n, or we can just return 0. Both those work. If n is equal to 7, we return 1. I feel like y'all are going to come up with something pretty brilliant, but we're going to kind of roll with this. Can I have 2 base cases in a recursive method? That seems a little bit weird. Can I do this? Yeah, we can have 2 base cases in a recursive method. Only one of them will actually execute, given a recursive call stack. So if we don't hit one of these base cases, we need to hit our recursive step. And what we want to do is return 1 if it's a 7. Otherwise, so let's check the rightmost digit. If n mod 10 is equal to a 7. This is going to get the rightmost digit and then see, is that exactly a 7? If it is, in that case, we're returning 1 plus and then going into our recursive call. Okay, our recursive call, we need to call our method, which is count 7. I've already considered the rightmost digit at this point, so I need to get rid of it. We'll take our current number, n, chop off the rightmost digit using divide 10. So that'll keep our calls going. Otherwise, if I'm still here after it's all said and done, what it means is the rightmost digit is not a 10. So I effectively want to return 0 plus count 7, chopping off the rightmost digit. Hopefully, some of you are recognizing that we don't actually need the 0 plus. We could just effectively keep going without adding anything. So I want to chop that off. Let's try this. Okay. Now, I'm looking forward to seeing some elegant solutions to this. Maybe we can condense these base cases down into a single base case, and we don't actually need to express it in 2 different ways. Hit me with a solution in Discord, and I'll be happy to take a look at that. Okay, so right now, this is a solution. This works, right? We have 2 base cases. That being said, given my recursive call stack, what do I mean? Each one of these test cases, they end by hitting one of these base cases. Not both, never both. It'll hit one of them. If my base cases aren't true, we'll hit the recursive step, which is effectively all of this. Notice that I effectively have 2 recursive steps here. Only one of those will actually be executed. So if the rightmost digit is a 7, I have found a 7. We'll add 1 to basically our sum total. But we're going to keep going with the recursive call. Now I want to chop off the rightmost digit. Otherwise, I'm effectively adding nothing, yet we still keep going. So here's a solution to count 7. Okay. Let's see. I have a practice question for us, which I'm going to throw up, and I'm going to give you, it's multiple choice. 2.5 minutes. What do you think? Let's go, but I didn't get around to making any Kahoot. All right, I want you to answer this question. I'm going to give you 2 minutes. A song, yeah, I have to find maybe some Monster Cat. It's definitely a song's worth. I'm going to put a timer up. 2 minutes, let's go. You can give me answers to this question in Twitch chat. Elise, I didn't really have time to find music. I thought about it, but gosh, it would take me almost 2 minutes just to get to some Monster Cap. Yes. Okay, so very happy with the responses I'm seeing. Our answer here is indeed Bravo 7. So what I like to do is trace this, because this is a lot like loops, guys, where when it comes test time, yeah, you can kind of look at it and think about it in your head and hope to get the right answer. But what I really recommend is kind of tracing it. So why don't we pull this to the side, and we'll pull up some notepad. Okay, so I've got mystery 5. We're going to ask, is B, this value, is it 0? No. Mod 2 equal to 0, we're effectively asking, is it even? Is it even? No. So we're going to return mystery of B minus 1, which is 4, plus 1. That's on the call stack. I'm going to step into this method call because I don't know what it is just yet. We're going to ask, is B 0? No. Is B mod 2 equal to 0? Yeah, this is an even number, so we're going to hit this return statement. We'll do mystery of B minus 1, which is 3, plus 2. This is on the call stack. I don't know what M3 is, so I'm going to step inside that, what mystery 3 is. First thing we're going to ask, is B 0? No. Is B even? No. So I hit this mystery down here, which is going to be mystery of B minus 1 plus 1. Right, let's step inside this call. We'll ask, is this 0? No. Is it even? Yes. We'll do mystery of B minus 1 plus 2. We'll step in here. Is it 0? No. Is it even? No. Do mystery of 0 plus 1. We'll step inside this call. Is it 0? Yeah. That is the height of our call stack. We hit the base case, it'll collapse. I can start solving things. So mystery 0 is 0. I'm going to just replace this with a 0. I can now solve mystery of 1. It is 0 plus 1, or just simply 1. I can solve mystery 2. It is 1 plus 2, 3. I can solve mystery of 3. It's 3 plus 1, or just simply 4. I can solve mystery of 4. It's 4 plus 2, or simply 6. And finally, we can solve mystery of 5. It's 7. So that's how we trace it. Okay. I'm going to give you this for homework. I want you to do count 8. You can DM me some solutions in Discord. We'll take a look at a solution tomorrow. And that's it, fam. Let's chill.